Hello, and welcome to the introduction about simplified IDoc monitoring with Libelle EDIMON. This video serves as an introduction covering an overview of the EDIMON software solution. The agenda for this introduction is a short overview of who Libelle is and what we are doing. We cover why we chose to develop and offer an IDoc monitoring solution. We present some of the basic concepts used and utilized within the EDIMON tool and an overview of the EDIMON Cockpit. We explain in detail the concepts of EDIMON Worklists and EDIMON Forms and present some advanced features towards the end. Let's start with who Libelle is and what we are doing. Libelle is the company that develops, sells, and supports the EDIMON solution. Libelle is headquartered in Stuttgart, Germany, and the US and Canadian market is serviced by our Atlanta office. Worldwide, there are currently more than 1,500 installations at almost 500 enterprise customers across all products offered. Libelle works with some of the largest SAP customers worldwide, with 80% of our customers running the SAP ERP software. The EDIMON IDoc monitoring solution is part of Libelle's Landscape and SAP Services division. There are two more divisions which might be interesting in the area of system refresh automation for SAP and in the area of data replication for SAP and non-SAP systems. Let's go over some of the background of why IDocs and monitoring of them is such an important topic. IDocs are important because of the simple fact that IDocs within SAP systems are a critical and essential aspect of how the business operates and how information and products move from suppliers to customers and move within the organization. Every single IDoc that fails is a potentially failed business process. A failed IDoc is an order that doesn't get processed or an invoice that doesn't go out. So, IDocs are highly critical for the business, and this is why it is so important to actively manage and monitor IDocs. The main challenge that is present when managing and monitoring IDocs within SAP systems is that there is typically not a single central interface to monitor all IDoc issues. It is often difficult to notice if an IDoc failed if the SAP users are not specifically looking for issues. Errors and issues are difficult to identify and fix. IDoc monitoring and management happens across multiple SAP T-codes such as BD87 or WE20. There are different places IDoc information is stored, accessed, and managed. Once identified, it is often cumbersome to fix the respective IDoc. There are often no clear responsibilities within the organization who monitors and who is responsible. So overall, with Libelle EDIMON, we want to make the IDoc monitoring more structured and organized, make it part of the regular day-to-day operation, make monitoring and management faster, less labor-intensive, and less repetitive for the SAP users and administrators. EDIMON is an SAP add-on that has been developed and is maintained by Libelle. It comes as a standard ABAP transport that is loaded into the SAP production system. EDIMON installs its own namespace /Libelle/EDIMON. After implementation, EDIMON is called with a simple T-code and provides SAP users and administrators with a single interface to monitor and manage IDocs. It will be an integrated part of the SAP end-user experience. The goal of EDIMON is to consolidate different transactions into one single interface. It pools important information into a single view and provides extensive management options that had to be accessed across multiple SAP T-codes with EDIMON. The availability of EDIMON functionality doesn't mean that the original transactions are replaced. Access to centralized functionality is provided in addition to the existing transactions. EDIMON is getting its IDoc data from the SAP EDI tables EDIDC, EDIDD, and EDIDS. This is where the tool regularly copies metadata into the own EDIMON namespace to present them to the tool and to the SAP user for management or processing. Let's look at some of the basic concepts of Libelle EDIMON. This includes the so-called run program, which regularly collects IDoc information. We also look at how EDIMON rules work in general with a basic notification example, whereby rules and reactions are covered in more depth in a separate section later. Overall, EDIMON is regularly collecting a large variety of important IDoc information. This includes data such as when each IDoc was created, when it was processed, and if it was processed successfully, or with warnings or with errors. EDIMON collects which SAP systems the IDoc came from, which is helpful if there are multiple SAP systems that are being monitored. EDIMON collects the origin of the IDoc and where it is going to, and if the IDoc was an inbound or an outbound IDoc. Additional data collected included the IDoc message types, including the respective base types. We collect message text, message class, and message number. Also, message variables are captured as SAP is building IDoc error messages based on placeholders that are replaced by message variables, so we want to capture those variables for each IDoc in order to know the exact data. EDIMON collects up to 3 segment value fields per message type, which we refer to as Object ID 1, 2, and 3. The term Object ID is important and used across the EDIMON tool as a reference to the defined segment fields. Object IDs are often holding the key information which the SAP user is looking for. It may hold specific material numbers, partner numbers, or distribution center codes assigned to an IDoc transaction. This will enable us to route the error message directly to the responsible person. All these parameters are regularly collected and copied into the Libelle namespace, providing highly valuable data to manage IDocs. This is exactly what EDIMON is doing next. After the information is collected, it is refined, filtered, presented, and provides vast management possibilities. The very heart of Libelle EDIMON is the so-called run program. The run program is configured within EDIMON and results in a standard SAP job that can be viewed, managed, and monitored with standard SAP means. One or multiple run programs are configured to run with different intervals and collect different information at different times. The run program may run for all IDocs at once or collect specific message types only or specific IDoc statuses or a combination of multiple parameters. It runs either as a scheduled background job or it is started anytime ad hoc in the foreground if specific information should be collected. It runs either as an RFC remotely or locally on the SAP system where EDIMON is installed. Each run job is collecting IDocs going back a designated time period measured in days. We don't want to collect all IDocs from the last 2 years every hour. That would be highly repetitive and add unnecessary workload to the system. As a rule of thumb, IDocs are frequently collected 3 to 5 days back, and a separate job runs once a day may collect older IDocs that are still open, unprocessed, or having issues. The run program is reading information about the IDocs from the IDoc tables and then transfer that information into the Libelle namespace. That way, we don't have to keep going back to the original tables for lookup. Within EDIMON, there is an architecture which is based on rules and reactions. After the run program collected IDoc statuses, let's say every 15 minutes or every hour, rules and reactions kick in. EDIMON rules continuously analyze collected IDocs if they match specific conditions. Typically, one or multiple numbers, such as a distribution center number from a segment field, can be stored in the rule. As soon as EDIMON captures a failed IDoc, it compares the rule with the IDoc information we have and sends, for example, an email notification to a specific user or group responsible for fixing the IDocs. Rules and reactions can be changed any time without touching the EDIMON core or without changing any of the underlying ABAP programs. It's simply a matter of configuration that can be changed dynamically. Rules can be created from scratch or derived from parameters from a failed IDoc state to catch an occurrence of the same condition in the future. Let's look at the 3 steps we just introduced in an example. In Step 1, IDocs are collected for, let's say, materials every 1 hour. Another job may collect IDocs for the vendor master every 15 minutes. In Step 2, there could be a rule kicking in configured to catch message status 69 in Matmos for inbound IDocs with message number 020 and message type M3. Further, this rule may only catch a specific material number or only a specific partner number from the IDoc segment field or IDoc control number. Finally, in this example, the reaction in Step 3 is configured to send an email to the owner or group of responsible parties in the organization. All collected information from the IDoc is available to be included in the notification email with a simple configuration step inside EDIMON. A quick overview on message variables. SAP is building its IDoc error messages based on placeholder. For example, message 031 says material &in-plant not handled successfully. The two ampersands are replaced with message variables of the actual values and what caused the IDoc to fail. Those exact variables are what we can find and want to filter for in EDIMON. Let's look at some of the features that can be accessed from the EDIMON Cockpit. Once EDIMON is started, the Cockpit is the main window and gives access to all information and all functionality available. View in the Cockpit can be restricted by SAP user so that each user only sees IDocs which are relevant to him or her. This screenshot is a section of the initial Cockpit view and gives key data broken down by SAP System. The example shows two SAP systems that are being monitored. For each system, we see how many IDocs are in a failed state in the column IDoc red. The next column shows IDocs in a warning state or IDocs yellow, and the column after that, IDocs green, shows the IDocs classified as properly processed. The next column lists the total number of unique IDocs collected by EDIMON. Reactions show how often EDIMON rules kicked in, and Run shows how often the run programs ran for this system. Finally, the last two columns indicate the date and time any EDIMON run program ran for this specific system. A simple double-click on a row of a system ID is drilling down one level deeper. Now we see all information for one specific system ID, in this case TA2 with client 800. From here, we have access to IDocs by message type. All other columns are the same information as in the previous screen, but are presented as row for each message type. With that, we again see classifications red, yellow, green, total number of IDocs, reactions, runs, and date time per message type. Please note that in this example, different message types were checked at different times, which indicates that multiple run programs are configured to operate on this system, or an ad hoc run program was started for a specific scenario. The next drill down gives a more granular view. This shows the exact IDoc message status for the selected message type. There are many different IDoc statuses that may lead to a classification into red, yellow, green. It is important to separate the IDocs by the exact message status number they are in. All columns to the right are again the same information as previously, but not filtered for that specific message type for that specific message status number. Now, from here, we can drill into the complete list of all IDocs matching the filter by selecting View of Details, which shows one row per IDoc. Alternatively, we can sidestep the detailed view by selecting View of Messages, which groups multiple IDocs with the same error message into one row, and the user drills down from there. Let's look at the option View of Details first before circling back to the Group view. This list is now giving the SAP user an in-depth view on the failed IDocs. For each IDoc, it provides the exact error message, message type, message class, message number, and message parameters 1 through 4. The column titled Rules lists if there is an EDIMON rule defined for this scenario. The column header next to it is called Notes and indicates if there are predefined custom notes. Notes are customer-specific help texts that can help an end user to fix IDocs. Usually, an organization has a certain way of managing issues or has standard number ranges that can be provided to the end user. EDIMON is also listing the object IDs, which are information from the IDoc segments or control records. As you may remember, EDIMON can include up to 3 segment fields or control records per message type. The column header provides the name for object IDs dynamically based on the message type, as each message type can have different object IDs defined. In this case, the object ID 1 is defined as materials. From this detail view, the SAP user is now able to take actions such as creating rules, reprocessing IDocs, or mass managing IDocs. Before going into more details on how IDocs can be managed, let's circle back to the group view. Sometimes a customer may have multiple IDocs that fail for the same reason. A mass update or mass process may cause hundreds or thousands of IDocs to fail with the same error message. The group view lists all identical issues in one line and lists the number of IDocs in that failed state in the last column. Double-clicking any of the rows is then listing the IDoc details the same way we saw it in the screenshot before and showed in the screenshot below. Also, please note in that second screenshots, there are 2 columns showing statuses EDIMON status and SAP status. These columns are default in the detail view and were partly off-screen in the previous slide. This is an important point to consider. SAP status is how SAP is seeing that IDoc and is always current. If an IDoc was red, got reprocessed into a correct state, it would immediately show as green. EDIMON status, however, is the status from the last time the run program saw the IDoc. If the run program runs every 15 minutes, it would go to green status on the next run and disappear from the list of faulty IDocs, but remain red in the meantime. A simple ad hoc execution of the run program would update the EDIMON status immediately. EDIMON is providing options of advanced IDoc search. Once we have all the information about the IDocs in a central place, we can provide a much easier interface to search for IDocs based on specific segment information. We can also search by object ID, where the SAP user may filter customer numbers, material numbers, factory numbers, or whatever is present in that segment. While column headers in the cockpit list the actual segment name, such as material number, the IDoc search window only shows generically object ID 1, 2, and 3, as different message types have different segment fields defined as object ID. EDIMON provides a simple interface to list the status history of any given IDoc. The status history includes SAP status history as well as the collected EDIMON information. It helps to easily identify the life cycle of an IDoc. Once a problematic IDoc is identified and the root cause that led to its failure is determined, the IDoc can be simply reprocessed directly from within the cockpit. It is processed either in the foreground if possible or as a background process. Foreground processing provides the option to directly going into the respective SAP transaction and update fields from there. EDIMON provides an option to mass change IDoc segment field. There might have been a process that kicked off 10, 20, or 100 IDocs and all of them failed for the same reason. There might be one field that was consistently provided incorrect. All selected IDocs of the same type can be mass changed from value A to value B. Additionally, certain conditions can be included to match before the update is taking place. This is a great feature considering that the alternative is a manual processing one IDoc at a time. Just as there is an option for mass updates, there is an option for mass archiving. This is very helpful when trying to clean up IDocs. By default, in SAP, there is no simple way to archive IDocs other than doing it one by one. With EDIMON, the user can mass select IDocs based on certain conditions, then simply mass archive by setting them to status 68. After archiving IDocs, the next logical step is to delete them. This too can be done on a large scale. The SAP user filters and selects multiple archived IDocs at once, then mass delete them. This helps with good housekeeping and keeps IDoc tables clean and organized. A powerful feature within EDIMON is the linking of object IDs to SAP T-codes. EDIMON provides a couple of handy shortcuts. Double-clicking on the IDoc number in the cockpit routes the user either to BD87 or to an EDIMON form. An object ID may refer to the material numbers for message type Material Master. Once configured, the Cockpit lists material in the column header for object ID 1. Each row would then include the material number for the respective IDoc when Material Master is the current message type. The link feature is now offering a shortcut for the user. When he or she is double-clicking a material number, the user will get routed to the SAP transaction MM03, taking along the material number. Each object ID can be linked to any T-code, and EDIMON supports up to 3 object IDs per message type. Now let's look at 2 concepts that are used within EDIMON: work lists and forms. These are 2 separate concepts that are targeting a similar outcome and functionality. The idea is to get users a better and simpler view on the IDocs and enable them to manage them quicker. IDocs are automatically added to a user work list based on a rule that has been configured. Imagine the work list is a bit like a ticketing system, where users are getting failed or problematic IDocs automatically assigned by a predefined algorithm. A specific user may get 15 or 20 IDocs assigned to their personal queue every day. An end user would log in, select Worklist, and see his or her queue of IDocs personally assigned that require attention. Individual work lists provide very similar information that are available in the Cockpit detail view. What is the IDoc number, what is the system ID, the message type, message number, and so on. Work lists also allow mass updates, mass archive, and mass change of IDocs. Once an IDoc goes onto a work list, each IDoc gets the work list state open defined as status 10. From here, the IDoc should get fixed and the user updates the status as, for example, in progress or completed. Multiple work list items can be selected and marked as complete, so they can drop off the queue. The work list has a very convenient and powerful IDoc editor built in. EDIMON users can edit predefined fields in IDocs directly from the work list. These are fields that have been configured by the administrator, and that configuration can be customized. For example, the editable work list fields may include material numbers or profit centers. End users provide one or multiple new and corrected values, then save and then reprocess the IDoc. The second concept in this context is called EDIMON Forms. Forms are a simplified view on an IDoc with predefined specific parameters that are displayed and can be managed. A standard IDoc may have up to 300 or 400 fields, whereby probably 80% of them are irrelevant to the specific issue that needs to be solved. Forms present a limited view, for example by displaying only 20 fields that are relevant to a sales order, an invoice, or a purchase order that failed. Forms display the information that has been pre-selected in a standard SAP way: header, body, and footer. Fields are now updated in the form. Information can be saved, and then the IDoc can be reprocessed. Next, let's look a little bit closer at the inner workings of EDIMON rules and reactions. In the beginning of this introduction, we touched on how rules and reactions work. Let's recap that and dive more into specifics. The run program collects IDoc information. The rule engine matches predefined rules with conditions that are presented to catch IDocs which match the conditions. The reactions are then triggering a predefined response. Overall, goals of rules and reactions is to automate as much as possible of the work of identifying issues and addressing the same. EDIMON already has all the relevant IDoc data collected and pre-selected to allow complex queries to run in a short period of time from within the Libelle namespace. From here, it is easy to filter out what is important or not, what is critical or not, and what may require immediate attention or escalations. The rule reaction engine can be thought of a bit like an Outlook email filter. If an email is received from a specific person at a specific date with a specific subject line, that email may get moved to a specific email folder for that subject. Except in EDIMON, we do this on a much larger scale to cover requirements of IDocs. Let's look at the way rules can be created. Rules are created either from scratch or based on certain conditions that already have occurred in the systems, leading to one or multiple IDocs to fail. We may select the SAP system, the message type, message status, field and message numbers, or message variables. Again, we can use object IDs, which are IDoc segment fields or IDoc control records. In this screen, we see 8 basic dimensions, but there are much more available. Rules can be simple or complex, whichever the individual scenario requires. Rules also evolve over time. Multiple rules may kick in for the same IDoc, and multiple reactions may be triggered from the same rule. As just mentioned, rules are typically created based on a failed IDoc state. From here, all selection criteria are pre-populated in the rule setup. After that, the selection criteria can be either narrowed or widened, whatever makes sense. Once created, the rule then shows in the EDIMON rule list. Also, any matching IDoc in the Cockpit will have a rule flag in the view of details. Rules can also be activated or deactivated based on customer requirements. We used a standard email as an example as a reaction type. However, this is only one of the several reaction types available. Let's look at the group of notifications first. Standard email works great for some, but different organizations have different preferences. Triggering an SAP mail instead of a regular email is often preferred as users can stay within the SAP application. SAP Mail also offers additional possibilities linking SAP transaction or linking EDIMON worklists to fix issues there. End users would not have to go back and forth between their email client and the SAP application. Another notification type is called C-Mail, which is an abbreviation for confirmation mail. It's a bit of a light version of the EDIMON worklist. Here, users must confirm the receipt of a notification and flag the completion of an issue. On the execution options, EDIMON provides an interface to execute SAP function modules, execution of SAP programs, or execution of an SAP event. This can help to programmatically execute certain steps for known issues. These execution options are typically configured together with the Libelle team during implementation. Finally, the integrations are the EDIMON worklist, which we will explain in detail later. CCMS and operating system interfaces help in executing steps in CCMS system on an OS level using standard SAP means. This is an example of an email notification from EDIMON. It is from a test system here at Libelle and slightly adjusted for demonstration purposes. First is a customizable subject line. If multiple IDocs fail for the same reason, a single email consolidates multiple failed IDocs into one message and lists how many IDocs failed or are in a specific selected other state. The email body starts with one standard text including originating system, message type, message status, message class, and message number. It also includes which EDIMON rule raised the reaction and at what time that reaction was raised. Next, the IDoc number with object IDs and error texts are displayed. This can be multiple entries if multiple IDocs failed. An additional customizable body can include object IDs, which could be order numbers or any other information from segment fields. This information, too, is repeated for each failed IDoc in the same message. The email notification is a powerful feature as it allows immediate notification to the exact user who is responsible, with all relevant data that is required for that user to assess the situation, prioritize issue resolution, and fixing the issue. All options from the email notification are available with the SAP Mail. Subject, header, and footer include the same information as just demonstrated. The advantages of an SAP Mail are again the possibility of embedding links to SAP transactions, to EDIMON worklists, or to a specific EDIMON selection. Now that we have looked at the basic concepts of Libelle EDIMON, reviewed the EDIMON Cockpit, explained EDIMON worklists and forms, looked at rules and reactions, let's have a look at some of the advanced features available. If an IDoc fails, SAP provides specific information what went wrong and how it can be solved in so-called long texts. These long texts are conveniently available from the EDIMON Cockpit and pre-selected for that failed IDoc state. The SAP application often provides a very helpful set of information for troubleshooting. Custom notes are an organization-specific extension to SAP long texts. Any organization may have specific number ranges or specific ways of handling certain issues. This can be included into EDIMON via custom notes. Custom notes can be created during implementation or appended anytime. Custom notes are visible in the cockpit and in the worklist with a custom notes icon. They are filtered and assigned similarly to rules, but typically with less granularity, as they don't require a very deep segmentation. The Table Compare feature allows rules to compare IDoc segment information with specific SAP tables. This was one of our customer requirements that IDoc might process okay, but there are certain business rules that should be applied. Let's say an IDoc processes highly critical information, and organizations want to add an additional layer of security. As an IDoc gets processed, a rule checks the validity of that IDoc information against an SAP table and eventually triggers an alarm or blocks the execution via an SAP function module. EDIMON provides access to field and filter information for each message type and access to partner profiles for each message type. This gives users and administrators a quick reference to underlying information. One more topic to cover as we reach the end of this introduction. EDIMON provides the possibility of exporting and importing rules. This is a feature targeted for the administrator during setup and maintenance of EDIMON. We enable users to export and import rules anytime. Some customers may have complex rules they want to manage, manipulate, or duplicate in a spreadsheet before importing the rules back into EDIMON. Rules can be exported and imported in their entirety, or if number ranges have been defined in SAP, only certain number ranges can be imported. This gives customers the option to maintain a set of certain rules in a spreadsheet and re-import them on demand. This concludes the introduction to Libelle EDIMON. We hope you gained valuable insights from the presentation. If you have any questions, would like more information in general or on a specific topic, or if you would like to schedule a software demonstration, please contact Libelle anytime.